Industrial robots can be found nearly everywhere in automated manufacturing today. They are used in a broad range of applications, from welding of car bodies in the automotive industry to the packaging of chocolates in the consumer goods industry. To be efficient, robots move very fast, and thus they are a source of danger for persons working in their environment. For this reason, the working areas of human and robots are normally separated by fences. However, fully automating industrial manufacturing may not always be the most economical option. This is particularly the case when human skills are required, such as situation-dependent responses and problem-solving abilities. When a robot cell is safeguarded by a protective fence, then entering the enclosure causes the robot to be switched off. While indeed the source of danger is shut down, the production process is also interrupted. To resume automatic production, the worker must ensure that no one is in the robot cell and must acknowledge this at the control system. This type of personnel safety provision prevents any interaction between humans and robots. By integrating a safety controller which safely monitors the angles of the robot axes, the position in space, and the velocity of the manipulator, ABB has opened the way for new and innovative robot applications. With the function EPS, Electronic Position Switch, the conventional limit switches used to restrict the working range of the robot are fully replaced by a software function. If, for example, due to a programming error, the robot attempts to access a forbidden access zone, it will be switched off by the safety controller. The interaction between a worker and a robot, such as for manually loading a gripper with a workpiece, becomes possible with the SafeMove function. With SafeMove, the safety controller supervises the safe standstill of the robot during the time the worker is within the hazardous zone. Furthermore, SafeMove allows limiting the robot movement to predefined zones in the space in order to enable safe coexistence of human and robot. It also allows restricting the traveling velocity of the robot to a preset value. To enable humans and robots to optimally complement one another while carrying out manufacturing tasks together, it is necessary that the position of the worker is spatially detected in a safe manner at all times. In principle, this can be achieved, for example, through camera systems which constantly monitor the workspace of the robot and the position of the worker and continuously transmit this information to the control system. If robot and human approach one another, the control system can then first reduce the velocity of the robot until it finally switches the robot off completely in case the distance between worker and robot falls below a preset distance. This method allows safe implementation of new semi-automated manufacturing strategies that were not possible up to now. The robot is assigned those tasks for which it is best suited, such as carrying and precisely positioning heavy loads. On the other hand, the human worker handles the tricky steps like mounting varying components onto an assembly for different product variants at the same time. With these new control and monitoring possibilities, more efficient workplaces become possible in the future, in which humans, as well as robots, can systematically contribute their strengths in collaborative manufacturing steps.